slide is about a parallel development model. In this model is a kind of structures SDLC methodology. This methodology attempts to address the long time interval between the analysis phase and the delivery of the system. A general design for the entire system is performed, and then the project is divided into a series of distinct sub-projects. Life-field application development. RAD-based methodology adjusts the SDLC pace to get some part of a system developed quickly and into the hands of the user. Most RAD-based methodology recommend that analysis use special techniques and computer tools to speed up the analysis, design, and implementation pace, such as case tools. Phased model. This methodology breaks the overall system into a series of versions that are developed sequentially. The team categories the requirements into a series of versions. Then the most important and fundamental requirements are bundled into the first version of the system. The analysis phase then leads into design and implementation. However, only with a set of requirements identified for version number 1. As each version is completed, the team begins work on a new version. Next model is prototype development. Prototype model that implements the main functions required by customers as a prototype and improves and complements them through customer feedback to create complete software. Prototyping-based model perform the analysis, design, and implementation phase concurrently. All three phases are performed repeatedly in a cycle until the system is completed. A prototype is a smaller version of the system with a minimal amount of features. Has some characteristics. User-oriented process model. Prototype is possible to understand customer requirements in detail. You can communicate with the customers through prototypes. Prototype development process included in the slide summarized and shown above. Please take a closer look at the picture. First step, planning and analysis, design, implementation has all three steps repeatedly for users' requirements feedbacks. And built a system prototype. First step is planning step. In addition to verifying the feasibility, we listen to the customer's key requirements and decide where to proceed with the project. Overall planning of project progress. And then requirements analysis, analyzing and organizing customers' needs. Creation of customers' requirements after extracting key requirements to be included in the prototype. And next step is prototype development. Prototype design based on the main requirements from the requirements analysis stage. Develop initial prototype to show the customer. This is a stage of development, but it is also a stage of prototype improvement that reflects requirements that are added, modified in later evaluation stages. Prototype evaluation is a check if customer requirements are satisfactorily reflected. If the user has additional requirements or improvements, return to the previous step. At this time, perform the improvement work. In some cases, the analysis of the needs may be re-executed. This is a case where the customer's requirements are incorrectly specified, which is not a good situation. Finally, we will develop an implementation. A prototype is now a real system. Since the prototype is usually a central requirements function, this part is implemented as a real system, and additional functions are implemented. Perform unit tests and code verification while developing. A prototype is not a finished product, so if the whole system is implemented, now run the test as a complete system. Integration test, system test, acceptance test. Subsequent steps such as acquisition, installation, and maintenance. Prototype model has some advantages. Prototype model provides a system for the users to interact with even if it is not initially ready for use. It helps users understand that the result can be checked in advance at the beginning of development. In the early stages of development, corrections and supplements can be identified in advance. Users can participate in analysis and design process to provide immediate feedback. But also has some disadvantages. Often the prototype undergoes such significant changes that many initial design decisions prove to be poor ones. Not easy to apply for the development of one-time or large-scale project. Since prototypes are made based on incomplete requirements, as a result, incomplete systems are calculated, and a large amount of manpower and time are invested in correction and supplementation. Discarded when moving to the next stage of prototype development. It can be neglected to manage the output document during the iterative process centering on the prototype. Customers may mistake prototypes for finished product, making unnecessary and excessive demands. Next methodology is Agile development methodology. This category focuses on streamlining the SDS by eliminating much of the modeling and documentation overhead and the time spent of those tasks. Project emphasizes simple, iterative application development. These categories use extreme programming-based methodology, which is described next. XP, extreme programming, was founded on 4 core values: communication, simplicity, feedback, and courage. Extreme programming-based model has some key principles: continuous testing, simple coding, and close interaction with the end user to build the system very quickly. Other development methodology. The spiral model is gradually developed into a complete system in order to minimize risks in system development. The spiral model has the following features. Risk analysis phase exists to minimize risk. A model that repeats the steps gradually. Suitable for large-scale systems with a high risk. A spiral model has developed a procedure as follows. Determine object, and then risk analysis, and next implementation and testing. Finally, evaluation and establishment of next steps. Determining object is analyze customers' requirements review feasibility, and decide whether to carry out the project. Establish specific goals for each stage of the project. One cycle spins and next cycle changes. Risk analysis. These steps to extract risks that are predicted based on the customer requirements and to develop countermeasure for the project. The purpose of this step is to minimize risks by extracting and resolving them. And implementation and tests. When the risk analysis is completed, select a development model that fits the system and development environment. Choose the model you normally use unless you are in a special situation. Evaluation and establishment of next steps. After the development and testing are completed, the customer evaluates it and decides where to repeat it. Usually, acceptance testing is done at this stage, and the result of satisfaction determines whether additional iterations are made. A spiral model has some advantages. The helical model allows for high-risk projects due to risk management. The customer's requirements can be applied in more detail, and the change requirements can also be applied. High customer satisfaction and quality for finished product, but also has some disadvantages. The project takes a long time. Project management becomes difficult as the repetition steps get longer. As risk management is important, you need a risk management expert. Next slide is about selecting the appropriate development methodology. Selecting a methodology is not simple, as no one methodology is always best. Many organizations have their own standard. Clarity of user requirements. RED methodology of prototyping is usually more appropriate when user requirements are unclear, as they provide prototypes for users to interact with early in the SDLC. Familiarity with technology. If the system is designed without some familiarity with the base technology, risk increases because the tools may not be capable of doing what is needed. Project should consist of a variety of skilled individuals in order for a system to be successful. 6 major skills sets on analyst should have: a technical skill, business skill, analytical skills, interpersonal skills, management skills, ethical. Analysis has some skills. Business analyst, categories of analyst: business analyst, system analyst, infrastructure analyst, change management analyst, project analyst, project manager, PM. Divided 5 categories. Project team's role: business analyst. Business analyst has analyzing the key business aspects of the system and identifying how the system will provide business value, designing the new business process and policies. System analyst has a role of identifying how technology can improve business process, designing the new business processes, designing the information system, ensuring that the system conforms to information system standards. Infrastructure analysts ensure the system conforms to infrastructure standards and identify infrastructure changes needed to support the system. Change management analyst has a role of developing and executing a change management plan and developing and executing a user plan. A project manager is managing the team of analysts, programmers, technical writers, and other specialists. He has developed and monitored the project plan, and he assigned resources, serving as the primary point of contact for the project. In this lecture, the characteristics of the software include logic, development, non-operation, flexibility, tangibility, marketability, and robustness. The system development life cycle consists of 4 stages: planning, analysis, design, and implementation. And additional maintenance. There are 6 major development methodology: waterfall method, parallel method, phased method, system prototyping method, design prototyping method, and agile method. There are 5 major team roles: business analyst, system analyst, infrastructure analyst, change management analyst, and project manager.